Hello students, this video will give you an introduction or the basics of patterns. So how will we define a pattern? An arrangement of a particular entity following few conditions is called pattern. So anything which we arrange using few conditions, that arrangement is called pattern. Let's see few examples using numbers. The first example is natural numbers. If you look here, 1, 2, 3, 4, it goes on. So the next number will be 5. So the condition it follows here is the next number will be 1 plus the previous number. So if you take 3, 3 is 1 plus the previous number. So 2 plus 1. So it is getting incremented by 1. So when you add 1 plus 1 it is 2, 2 plus 1 it is 3, 3 plus 1 it is 4. So the next number will be 4 plus 1 which is 5, and the next number will be 5 plus 1 which is 6, and it goes on. Now whole numbers, we know that it begins with 0. So again here it is getting increased by 1. So here also it follows the condition, add 1 to the previous number to get the number. So to get the next number, I will add 1 to the previous number, 4 plus 1. So the next number is 5. Another example, even numbers. So here the difference, or you are adding 2 to the previous number. So to get the second number, you will add 2 to the first number. So it is getting incremented by plus 2. So the next number is 8 plus 2 which is 10. For odd numbers it starts with 1, and 1 plus what will give us 3? 2. And 3 plus 2 is 5. 5 plus 2 is 7, and it goes on. So the number, so this number will be 2 plus the previous number. So 9 plus 2 is 11. So this is how we get the next number. Now Fibonacci numbers. I am not sure how many of you would have heard this earlier. So let me tell you how will we form this series of numbers. Now 0 is the first number of the Fibonacci series. So 0 and 1 is the second number. So the next number will be the sum of the previous two numbers. So this number is the sum of 0 plus 1. Now coming here, to get 2 we will have to add the previous two numbers. What are the previous two numbers? 1 plus 1. To get 3 we will add the previous two numbers. What are the previous two numbers? 1 plus 2. To get 5, we will add the previous two numbers. What are the previous two numbers? 3 plus 2. So, to get a number in the Fibonacci series, we will have to add the previous two numbers. So, the sum of the previous two numbers is the value for this particular place. So, previous two numbers are 5 and 8. 8 plus 5 will give us 13. So to find the next number, to find this number, I will have to add the previous two numbers. Which are the previous two numbers? 13 and 8. So 13 and 8 is 21. So this is how, this is a condition how Fibonacci numbers are formed. So to find a number, we will have to add the previous two numbers and write the result. So the next number will be 21 plus 13, and it will go on. So there are two types of patterns. Now linear pattern and non-linear pattern. Linear pattern is the pattern where you will have the difference as the same between any two consecutive terms. For example, if you take here 3 and 4 are consecutive terms, 5 and 6 are consecutive terms. The difference between 3 and 4, 4 minus 3 is 1. 6 minus 5 is 1. If you see, it is getting increased by 1. So the difference between any two consecutive numbers, 2 minus 1 is 1, 6 minus 5 is 1, 4 minus 3 is 1, 3 minus 2 is 1. So the difference will be the same for any two consecutive numbers. That is called linear pattern. For a non-linear pattern, if you look here, 1 minus 0 is 1. The difference between 0 and 1 is 1. The difference between 1 and 1 is 0. The difference between 2 and 1 is 1. So the difference here is, you are adding 1, you are adding 0, you are adding 2, you are adding 1, you are adding 2. So if you look at the other series, it is plus 1 throughout. Again here it is plus 1 throughout. It is plus 2 here throughout, and again it is plus 2 here throughout. So the difference between any two consecutive terms is same for the first 4 patterns. But here it is not having uniform difference. It is having 1, 0, 2, 1, 2, and here it is 8 minus 5 will give you 3. So the difference is not same here. So when the difference is same, that patterns are called linear patterns. So in our syllabus we have problems related to linear patterns. So what is a linear pattern? So linear pattern is a sequence of numbers that have the same difference between any two consecutive terms. For example, 2, 5, 8, 11, 14, 17, 20. Here I have a sequence of numbers. So if you take any two consecutive terms means a number and the next number, those are consecutive terms. So if you take any two consecutive terms, the difference between them will be the same. For example, I take 5 and 8. 8 and 5, the difference is 3. 14 and 17. 17 and 14, the difference is 3. 2 and 5, the difference is 3. 17 and 20. 20 and 17, the difference is 3. So, throughout you have a difference of 3. This type of sequence is called a linear pattern. And in a pattern, each number in a pattern is called a term. So 2 is the first term of this pattern, 5 is the second term, 8 is the third term, 11 is the fourth term, and it goes on. So we don't know where this pattern is finishing. It is continuous. So each term in a pattern is called term. So we represented this linear pattern using a series of numbers. So now I have another example of a linear pattern. 4, 7, 10, 13, and it goes on. So here the linear pattern is represented using numbers. Now I will represent the same linear pattern which is represented here using numbers using lines. So here you can see a pattern represented using lines. Now if you look at the first figure in the pattern, we have 4 figures now. The first figure has 1, 2, 3, 4 lines. 4 lines. And the second figure has 1, 2, 3, 4, 5, 6, 7 lines. The third figure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 lines. Now the same numerical pattern is replaced using lines in the form of figures. So I have the first 4 figures of this pattern. So this kind of representation of a linear pattern using figures is called geometric pattern. This geometric pattern will also be of the form of linear patterns. In this syllabus, we have only linear patterns to be considered. So, linear pattern means a sequence of numbers that have the same difference between any two consecutive terms. So, the same difference. 4 and 7 has 3 as the difference. 10 and 7 has 3 as the difference. 13 and 10 has 3 as the difference. So, any two consecutive terms you take, the difference should be same throughout. That pattern is called a linear pattern. So this is the numerical representation of a linear pattern, and this is a geometrical representation of a linear pattern. So in the next video we will learn how to find a particular number in a pattern. For example, if I take 4, 7, 10, 13, I know it is getting increased by 3. So here I will add 3 and I will write 16. So first, second, third, fourth, fifth. 16 is the fifth term of this pattern. So it is possible for me to find 16 here because I just have to add 3 here. The next number will be 16 plus 3, which is 19. So I can find the next number by just adding 3 to it. But it's not possible for me to find the 200th or the 1000th term of this pattern by adding in this way. It's not possible for me to add and find out the 1000th term or the 500th term or the 200th term by using this way of adding. So we have a formula which will help us to find a particular term in a pattern. This we will discuss in the next video. From this chapter, we may get questions of this form. Find the next number in the pattern. So we will be asked to find the next number. So this may be a linear pattern or may not be a linear pattern. We have to find out what is the condition this particular pattern of numbers follows. So let's look at the first example. So if you look here, the first number here is 1 and then it is 4, 7, 10, and we are asked to find the fifth number. First, second, third, fourth. First 4 numbers are given and the fifth number is to be found. So if you look here, 1 and 4. 1 and 4, 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. So it is getting increased by 3. So 3. So the next number will be 10 plus 3, which is 13. Now here 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18. So 18 plus 4 is 22. So here it is a plus 4. So the first two patterns which we saw now are linear patterns because they have uniform difference between any two consecutive terms. 10 minus 7 is 3, 4 minus 1 is 3, 13 minus 10 is also 3. Again here the uniform difference here is 4. 14 minus 10 is 4, 22 minus 18 is 4. So these two are linear patterns. Now look here, we have 1 and 5. So 1 plus 4 is 5. 5 plus 1 is 6. So the difference here is 4. So 1 plus 4 gives us 5 and the difference here is 1. So from here we can conclude that this is not a linear pattern. So it does not fall under linear pattern. It does not have the same difference between two consecutive terms. So we have to find other conditions which this particular pattern is following. So we will have to use trial and error method. Now looking at this pattern, the numbers are getting incremented. So I have 1 and 5, 6. Let me think if this has any relation with 6. Yes, 1 plus 5 gives me 6. So now the next number is 11. So 5 plus 6 gives me 11. 11 plus 6 gives me 17. This is an example of Fibonacci series. A number is the sum of the previous two numbers. So 6 is the sum of the previous two numbers, which is 5 and 1. 5 plus 1 is 6. 17 is the sum of 11 and 6, 17. And 28 is the sum of 11 and 17. So 17 plus 28 will be the number which will be present at this position. So the number which will come here will be the sum of the previous two numbers, 17 plus 28. Sum of 17 plus 28 is 45. So 45 is the answer. This does not come under the sequence of linear patterns. It is a Fibonacci series. Now look here. 1, 4, 9, 16, 25. 1 and 4, the difference is 3. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7 is 16. So we don't find any uniform difference. So we have to think about other ways to find out what condition this particular pattern follows. So if we see here, 1 is a square number, 4 is a square number, 9 is a square number. So 1 is 1 square, 4 is 2 square, 3 square. Yes, this is 4 square, this is 5 square. So the next number will be 6 square, which is 36. Again, this is not a linear pattern. Now 3, 7, 11, 15. 3 and 7, the difference is 4. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 4 is 19. So this is a linear pattern because it is having a uniform difference of 4. Alright. So these questions may come in our MCQ section. So the other topics related to linear pattern, which is we have to find the particular term or find the sum of the numbers in a pattern. So if we are asked to find the 200th term of this linear pattern, it's not possible for us to add and find out. So we will have to apply a formula which we will learn in the next video. Thank you.